Good morning, dear student. Nowadays, I am discuss a Laplace transformation under engineering mathematics for BTech students and BSc students and other competitive exam for mathematics. As a relate of the BTech student of a third unit, today I am discuss most important shifting theorem, first and second, how can relate the numerical and their examples. First, I am discuss the first shifting theorem of Laplace transformation. First shifting theorem, shifting theorem. First shifting theorem of Laplace transformation if L Ft is equal to Fs, then L e to the power At Ft is equal to F S minus A is a first shifting theorem of Laplace transformation where S is greater than A. S is greater than A. Now second shifting theorem of Laplace transformation is if L Ft is equal to Fs and Gt is equal to F t minus A at t is greater than A 0 at t is less than A, then L Gt is equal to e to the power As L Ft. It means L Gt is equal to e to the power As e to the power As Fs, e to the power As Fs. This is a very important for Laplace transformation. This theorem is important for your examination and use of the solving of Laplace transformation examples and numericals. So you can note down this theorem. Now next is change the scale property. Change of scale property. Property of Laplace transformation of Laplace transformation. If L Ft is equal to Fs, then for n is equal to 0, 1, 2, 3, dot dot L F80 is equal to 1 upon A F S upon A. L F S upon A. This changement is a Laplace transformation. If Ft is equal to Fs, then for L, F80 is equal to 1 upon A, Fs upon A. Now, next is Laplace transformation of derivative. Laplace transformation of derivative. First derivative of Laplace transformation and second derivative of Laplace transformation. Laplace transformation of derivative and their theorem. You can note down if L Ft is equal to Fs, then for n is equal to 1, 2, 3 dot dot for real number of n. L f to the power n t is equal to s to the power n fs minus s to the power n minus 1 f0 minus s to the power n minus 1 f dash 0 minus dot dot minus p s f to the power n minus 2 0 minus f n minus 2 0, where L f to the power n t fs is defined f to the power n stand for is defined as or stand for, it means f to the power n t is equal to d to the power n upon dt to the power n ft. Now, this is a very important for Laplace transformation of derivative. Now, proof. You can note down this. L f to the power n ft is equal to 0 to infinite e to the power minus st into f to the power n t dt. At n is equal to 1, it stands for first derivative. First derivative of Laplace transformation. Now we can write we can write L f dash t is equal to 0 to infinite e to the power minus st into f to the power f dash t into dt. Now you can put solve this integral by Eilert method. First is exist of integral e to the power st. Now first is exponential, algebraic. First is algebraic. Now you can note down e to the power minus st integral 0 to infinite f dash t dt minus integration 0 to infinite bracket differential of first function e to the power minus st and integral of second function f dash t dt bracket close into dt. Now solve this e to the power minus st into f t bracket close limit 0 to infinite. Now this minus minus plus integral 0 to infinite bracket e to the power minus st upon s. Now no into s into ft dt. Now putting the value of 0 to infinite, you can note down, solve this. If putting the infinite, e to the power infinite is equal to 0, 0 into 0 equal to 0, minus value of putting the 0 in a t, e to the power 0 is equal to 1 into f0. Now this s is a common integral 0 to infinite e to the power minus st into ft dt. This is a Laplace. Is also known as fs. Now L f dash t is equal to minus f0 plus s f s. This is a first derivative of Laplace transformation. First derivative of equation is first L f dash t is equal to minus f0 plus s f s. Now you can write now L f dash t is equal to, you can note down, s fs minus f0. Now you can say the equation number first. And now you can put the second, n is equal to 2 at n is equal to 2 is also known as second derivative of Laplace transformation. Laplace transformation is a second derivative of Laplace transformation. You put in the Laplace transformation function L f double dash t is equal to integral 0 to infinite e to the power minus st into f double dash t into dt. You can solve by part integral, first and second. First is let e to the power I st. Now you can write e to the power minus st and integration of ft, integration of 0 to infinite, integration of f double dash t into dt. Now second is this integral 0 to infinite bracket differential of e to the power minus st into integration of second function f double dash t dt bracket close into dt. Now solve this e to the power minus st into f dash t and limit is 0 to infinite, and solve this integration. Minus minus is minus plus integral 0 to infinite s e to the power minus st into f dash t into dt. Now putting the value of integral 0 to s e to the power minus st into f dash t is, now solve this. I have also find the value of f dash t. F dash t, f dash t is this. You can put this or find out the value of 0 to infinite in e to the power minus st into f dash t. If value is put in the infinite, value is 0, minus value the put in the 0 is f dash 0. Now write this as integral 0 to infinite e to the power minus st into f dash t is a first derivative of Laplace. Now putting the value of equation first. Now putting the value of equation first is minus f dash 0 plus s l f dash t. Now put the value in equation first. In equation first, L f double dash t is equal to, put the value of L f dash t. L f dash t is equal to, it means s square fs now minus s f 0 minus f dash 0. This is known as the second derivative of Laplace transformation. Second derivative of Laplace transformation. And now second equation or second derivative of Laplace. If I let L f dash t is equal to s square fs minus s f0 minus f dash 0 is a second equation, is a second equation. Therefore, if putting n is equal to 3, then third derivative of Laplace transformation L f triple dash t is equal to integral 0 to infinite e to the power minus st into f triple dash t dt. In equation second, L f double dash if triple dash t is equal to, putting the value of third, s cube fs minus s square f0 minus s f dash, no, f dash 0 minus f double dash 0. This is a third derivative of Laplace transformation. This is a third derivative of Laplace transformation. Both are very important. Both are very important to solve the Laplace transformation. You can note down this theorems for Laplace transformation and solve more example and more problems to help your examination. Please, you can note down this session. This is a very important. Please like and subscribe to my channel. If some query are exist, then you comment my videos and promote the session. I have